Have you ever wanted to contribute to a project that supports multiple versions of Python, but aren't sure how you would easily test all the versions? Or did you ever want to contribute to a project that uses another Python version than you currently have installed? Are you curious about the latest and greatest versions of Python? Maybe you'd like to try out these new features, but you don't want to worry about messing up your development environment. Luckily, managing multiple versions of Python doesn't have to be a hassle when you use pyenv. Hi, my name is Johan Vergeer, and in this course I would like to provide you with a great overview of how to maximize your time spent working on projects and minimize the time spent with headaches trying to use the right Python version. In this course, you will learn how to install multiple versions of Python on your machine, install the latest development version of Python, switch between the installed versions, use virtual environments with pyenv, and finally activate different Python versions and virtual environments automatically. The examples in this course are created on macOS. I've also used pyenv on Linux, which works just as great. Pyenv isn't supported on Windows, but there is a similar project called pyenv Win. We won't go into pyenv Win in this course, but when you are in Windows, feel free to check this out. This is an advanced course which requires you to have knowledge about a couple of things. First, running shell commands like cat, ls, pwd, etc. This course assumes you know these commands. And installing dependencies using a command line interface. You might even have to do some debugging when you run into issues. Installing pyenv is pretty straightforward when you know your way around the command line, but some people run into issues every now and then. So, without further ado, let's get started in the next lesson with discussing why you would use pyenv and not just the Python version that comes installed on your system. So, why not just use System Python? System Python is the Python that comes installed on your operating system. If you're on a Mac or Linux, then by default, when you type Python in your terminal, you get a nice Python REPL which uses System Python. So why not use it? One way to look at it is that this Python really belongs to the operating system. After all, it came installed with the operating system. That's even reflected when you run the which command. Here, Python is available to all users as evidenced by its location user bin Python. Chances are this isn't the version of Python you want either. Python 2.7.16 is the system Python at this moment, which is no longer supported and should not be used for Python development as of January 1st, 2020. To install a package into your system Python, you have to run sudo pip install, which I won't run because I don't want to pollute my system, and even if you wanted to, macOS won't allow it. That's because you're installing the Python package globally, which is a real problem if another user comes along and wants to install a slightly different version of the package. Problems with multiple versions of the same package tend to creep up on you and bite you when you least expect it. One common way this problem presents itself is a popular and stable package suddenly misbehaving on your system. After hours of troubleshooting and Googling, you may find that you've installed the wrong version of a dependency, which is ruining your day. Even if your Python version is installed in user local bin python 3, you're still not safe. You will run into the same permission and flexibility problems described earlier. In addition, you don't really have much control over what version of Python comes installed on your OS. If you want to use the latest features of Python and you're on Ubuntu, for example, you might just be out of luck. The default versions might be too old, which means you'll just have to wait for a new version of your OS to come out. Finally, some operating systems actually use the system Python for operation. Take Yum, for example, which makes heavy use of Python to do its job. If you install a new version of Python and aren't careful to install it into your user space, you could seriously damage your ability to use your OS. Now that you've learned why you should not use System Python, let's move on to the next lesson where you're going to learn what a package manager can do for you. Now that you've decided not to use System Python, the next logical place to look is package managers. Programs such as apt, yum, brew, or port are typical next options. After all, this is how you install most packages to your system. Unfortunately, you'll find some of the same problems using a package manager. By default, package managers tend to install their packages into the global system space instead of the user space. Again, these system-level packages pollute your development environment and make it hard to share a workspace with others. Once again, you still don't have control over what version of Python you can install. It's true, some repositories give you a greater selection, but by default, you're looking at whatever version of Python your particular vendor is up to on any given day. Even if you do install Python from a package manager, consider what would happen if you're writing a package and want to support and test on Python 3.7 up to Python 3.9. What would happen on your system when you type Python 3? How would you switch quickly between the different versions? You can certainly do it, but it is tedious and prone to error. Never mind the fact that you want, for example, PyPy, Jython, or Miniconda. Then you're probably just out of luck with your package manager. With these constraints in mind, let's recap the criteria that would let you install and manage Python versions easily and flexibly. First, install Python in your user space, so you have full control and you will have no interference with other users. Second, install multiple versions of Python, which will allow you to test your project with multiple Python versions or work on multiple projects with different Python versions in your user space. Thirdly, specify the exact Python version you want for each specific project. And lastly, switch between the installed versions so you can try stuff out on multiple versions, run tests with multiple versions on a single project, or easily upgrade the Python version for a project. pyenv lets you do all of these things and more. Now that you know why pyenv would be useful, you'll learn how to install pyenv on your operating system in the next lesson. In this lesson, you're going to install pyenv, but before you can install pyenv itself, you're going to need some operating system specific dependencies. These dependencies are mostly development utilities written in C and are required because pyenv installs Python by building from source. In the real Python article that comes with this course, you will find how to install build dependencies for the most common operating systems. You'll find a link to this article in the description. So now you can pause this video, move to the article to install the build dependencies, and then come back here to install pyenv. Now that you've installed the build dependencies, you're ready to install pyenv itself. I recommend using the pyenv installer project, which is as simple as running the command displayed on screen in your terminal. If you're using another shell like zsh or fish, then replace bash with the name of your shell. I've already installed pyenv, so I don't have to run this command anymore. Before we continue, you should check your terminal configuration file, which is, depending on the shell you're using, .bashrc, .zshrc, or .profile. It should contain something like the following, which sets the path to pyenv and initializes pyenv when you start the terminal. I've noticed pyenv installer changed the commands a bit over time, but it should be similar. When your terminal configuration file doesn't contain these commands, then you can copy them from this lesson's description. If you would like to know more about the pyenv installer project, you will find a link to the project's GitHub page in the description. A couple of plugins will be available to you after running pyenv installer. pyenv, which is the actual pyenv application. pyenv virtual env for creating and managing virtual environments with pyenv. You will learn more about this plugin later in this course. pyenv update, which is a plugin for updating pyenv itself and all pyenv plugins. pyenv doctor, a plugin to verify that pyenv and build dependencies are installed. And finally, pyenv which ext, a plugin to automatically look up system commands. Now that everything is set up, let's continue with installing a Python version using pyenv in the next lesson. Now that you've installed pyenv, installing a specific version of Python is the next step. You have many versions of Python to choose from, and to see all available Python versions, you can run the command pyenv install -- list. This is a very long list that might be tough to scroll through, so let's use the power of grep to see all available CPython versions for version 3.8 and 3.9. So let's type pyenv install -- list grep with a certain filter. And if you would like to know which versions of Jython can be installed by pyenv, you can figure that out just as easy by typing pyenv install -- list grep Jython. Once you've figured out which version you want, you can install it with a single command. pyenv install -v 3.9.1. The -v flag is added so pyenv will show what it is doing. Installing a version might take a while because pyenv is building from source, but I have fast-forwarded so you don't have to wait until the installation is finished. For the rest of the course, the examples assume you've installed CPython version 3.9.1, but you're free to substitute these values for the Python versions you actually installed. Also note that the system Python version in the examples is 2.7.12. Let's have a look in the next lesson where pyenv actually installed Python 3.9.1. I will start with an example that will demonstrate how pyenv works, and when you're following along, you might not want to run these commands just yet, because I will show you an even easier command to remove Python versions after this. As mentioned before, pyenv works by building Python from source, and each version that you have installed is located nicely in your pyenv root directory. As you can see, I have already installed a couple of versions before this course, which I used for several projects I'm currently working on. So, because all versions installed by pyenv are located in the .pyenv/versions directory and they are built from source, it is very trivial to remove them using the rm command. And when we have another look at the contents of the .pyenv/versions directory after running the rm command, we can see that version 2.7.15 is indeed removed. Now that you have seen where pyenv stores the Python versions and you've learned the hard way to remove them, I've reinstalled Python 2.7.15 and cleared my terminal to show you a much easier way to uninstall a Python version. When you were following along, this will be a good point to continue. Just like any self-respecting dependency manager, pyenv also has a built-in way to uninstall versions with the pyenv uninstall command. Instead of listing the pyenv versions directory like you did before, you can also just use another pyenv command. This will show all versions that are installed by pyenv. The asterisk indicates which Python version is active currently, which is system Python. You might be wondering how pyenv knows which Python version should be used. You'll be pleased to know there is no magic going on here, because pyenv simply sets the global Python version in a file that's located at .pyenv/version. As you might have noticed by now, you're still using system Python by default. This will also be confirmed when you run python-v or when you have a look at which Python version you're currently using. This might be surprising, but this is how pyenv works. Pyenv inserts itself into your path, and from your operating system's perspective, that is the executable that is getting called. If you want to see the actual path, you can run pyenv which Python. In the next lesson, you will start to use the new Python version you have just installed with pyenv. Let's start by looking at the Python versions that are currently available with the pyenv versions command. As you can see by the asterisk, system Python is still enabled, so let's change that. You can change the Python version with the pyenv global command. So let's run pyenv global 3.9.1 and check the current Python version, after which you will see that it is set. And when you want to turn back to system Python, just run pyenv global system, check the current Python version, and you will see that you are back to using system Python. You can now switch between different versions of Python with ease, but this is just the tip of the iceberg. If you have many versions that you want to switch between, typing these commands consistently will be tedious. We just touched the basics. And later on in this course, you will learn more convenient ways to manage your Python versions. In the next lesson, we'll have a look at some pyenv commands. Pyenv offers many commands. You can see a complete list of all available commands with their descriptions using pyenv-help. Each command has its own --help flag that will give you more detailed information about that command. For example, if you wanted to see more information on the shims command, you could run pyenv shims-help. Another option to get information on a specific pyenv command is the pyenv help command. So pyenv help shims will give you the same result as the --help flag. The help message describes what the command is used for and any options you can use in conjunction with the command. In the next lesson, we'll go over a couple of the most common commands. As you know by now, pyenv comes with a lot of built-in commands. In this lesson, we'll go over the most important ones, starting with the pyenv install command. You've already used the install command in a previous lesson. This command can be used to install a specific version of Python. As you have seen before, you can use pyenv install --list, maybe with grep, to list all versions that you can install with pyenv. If you want to see all compilation output while installing, you can run pyenv install with the --verbose flag. Once you have installed a couple of versions, you can use the pyenv versions command to display all of the currently installed Python versions, including system Python. If you only care about the version that is currently activated, you can run pyenv version, which is similar to pyenv versions, but only shows you the current active Python version. The which command is helpful for determining the full path to a system executable. Because pyenv works by using shims, this command allows you to see the full path to the executable pyenv is running. For example, if you wanted to see where pip is installed, you could run pyenv which pip. The output displays the full system path for pip. This can be useful when you've installed command line applications. The global command is yet another command you've already seen in a previous lesson, which is very useful for setting the default global Python version. You will learn how to override the global Python versions for each of your projects in a minute. So when you want to set the global Python version to 3.9.1, then just run pyenv global 3.9.1. The local command, on the other hand, is often used to set a project-specific Python version. So let's move into a project directory and set the version to CPython 3.8.7 for this project by running pyenv local 3.8.7. This command creates a .python-version file in your current directory that contains the Python version for this project. If you have pyenv active in your environment, this file will automatically activate or deactivate this version for you. So when you check which Python version is used, you will see it is the one you just set with the local command. Now, when you move out of the project directory and check the Python version again, you will see that the global Python version 3.9.1 is used. The shell command is used to set a shell-specific Python version. For example, if you wanted to test out the 3.9 dev version of Python, you can just install it And next, run pyenv shell 3.9-dev. This command activates the version specified by setting the pyenv version environment variable. This command overrides any application or global settings you may have. If you want to deactivate the version, you can use the -- unset flag. In this lesson, you learned the most important pyenv commands. You might also have noticed that the Python version can be set in a couple of ways, which we'll explore further in the next lesson. One of the more confusing parts of pyenv is how exactly the Python commands get resolved and what commands can be used to modify it. As mentioned in the previous lesson where we looked at the pyenv commands, there are 3 ways to modify which version of Python you're using. So how do all these commands interact with one another? The resolution order looks like this. Pyenv starts to look for the pyenv version environment variable, which is set with the pyenv shell command. When the pyenv version environment variable isn't set, then pyenv will check whether a .python-version file is found in the current folder or one of the parent folders, which would have been created by the pyenv local command. When no .python-version file is found, then pyenv will check which version is set in the file located at home.pyenv/version with pyenv global. And when no version is set there, pyenv will use system Python. Now let's have a look in the terminal what this exactly looks like. Let's start with the pyenv version command. You will see that currently system Python is used, which means that at this moment pyenv doesn't really do anything for us. Let's start to apply its power by running pyenv global 3.9.1 and have another look at the output of pyenv version. You can see that now pyenv wants to use 3.9.1 as our Python version. It even indicates the location of the file it found. That file does indeed exist, and you can just cat its contents. But now you would still have to change the Python version with the pyenv global command each time you want to switch projects, which isn't very convenient. Let's fix that with the pyenv local command. Let's move into the project directory, run pyenv local 3.8.7 if you haven't already done so in the previous lesson, and have another look at the output of pyenv version. Here again, pyenv indicates how it would resolve our Python command. This time it comes from .python-version in your project directory. The searching for .python-version is recursive, which can be proven by creating a new directory within the project, moving into it, and running pyenv version. Even though there isn't a .python-version file in the subdirectory, the version is still set to 3.8.7 because the .python-version file exists in a parent directory. So now you can use the system Python interpreter, set the Python version to be used globally, and set the Python version to be used for a single project. But what if you just want to experiment with another Python interpreter? For example, when you want to try some new features of a new dev release. Just run pyenv shell 3.9-dev, in the case you want to test 3.9-dev, and check the version. All the pyenv shell command did is set the pyenv version environment variable, as you can see when you echo it. In this lesson, you have learned how exactly pyenv resolves the Python command. In the next lesson, we'll have a look at another very powerful concept used by Python developers, virtual environments. Virtual environments are a big part of managing Python installations and applications. If you haven't heard of virtual environments before, you can check out the video course Working with Python Virtual Environments here on Real Python. Virtual environments and pyenv are a real match made in heaven. pyenv has a wonderful plugin called pyenv virtual env that makes working with multiple Python versions and multiple virtual environments a breeze. If you're wondering what the difference is between pyenv virtual env, and tools like virtualenv or venv, then don't worry, you're not alone. Here's what you need to know. pyenv manages multiple versions of Python itself. Virtualenv or venv manages virtual environments for a specific Python version. pyenv virtualenv manages virtual environments across varying versions of Python. If you're a diehard virtualenv or venv user, don't worry, pyenv plays nicely with either. In fact, you can keep the same workflow you've had if that is what you prefer. So I think pyenv virtualenv makes for a nicer experience when you're switching between multiple environments that require different Python versions. The good news is that since you use the pyenv installer script to install pyenv, you already have pyenv virtualenv installed and ready to go. So let's create your first virtual environment using pyenv. Open the terminal, make sure you are in the project directory, and type pyenv virtualenv 3.9.1 pyenv-course. With this command, you created a new virtual environment named pyenv-course, which uses Python version 3.9.1. Technically, specifying the Python version is optional, but you should consider always specifying it so you're certain of what Python version you're using. The environment name is just a name for you to keep your environment separate, and a good practice is to name your environments the same as your project. Let's have a look in the .pyenv/versions directory, where you will see that the pyenv virtualenv command created a virtualenv inside the 3.9.1 version and added a symlink to that virtualenv in the versions directory. When you have a look at the current output of pyenv versions, you will see that the newly created virtualenv is also added, which means you can treat a virtualenv the same as any other installed Python version. Now let's use the virtual environment you've just created by running pyenv local pyenv-course inside the project directory. You've seen the pyenv local command before, but this time, instead of specifying a Python version, you specify an environment. This sets the value of the .python-version file in your current working directory to the virtual environment name. You can see the Python executable is pointing to the virtual environment when you run pyenv which Python. If you look at any executable this environment provides, you will see the same thing. Take, for example, pyenv which pip, which will show you that the pip executable is also located in the virtual environment. Now that you know how to create virtual environments with pyenv, let's put everything together in the next lesson and work with multiple environments. Putting everything you've learned together, you can work effectively with multiple environments. Let's assume you have the following versions installed. Now you want to work on two different projects named Bree and The Shire. Bree supports Python 3.8.7 and The Shire supports Python 3.9.0. You can see that by default, you are using the system Python, which is indicated by the asterisk in the Python versions output. First, let's move into the workspace directory, create a new directory for the Bree project, move into this directory, create a virtual environment as we have learned in the previous lesson, which we'll also name Bree, and set the local interpreter for the Bree project. Once you've done these steps, the Bree project is ready to go. So let's clear the screen, move back into the workspace directory, and create another folder for the Shire project. Next, we'll create another virtual environment for the Shire by moving into the project directory, checking the currently activated Python version, which is System Python, create a new virtual environment, and set the local interpreter to this new environment. Now that you have configured the environments for each project, switching between them will be a breeze, as the virtual environments will automatically activate when you move into the project directories. At this moment, we're still in the Shire project, which uses the eponymous virtual environment. So let's clear the screen again, move out of this project and back into the Bree project, where you will see that it uses the Bree virtual environment. So no more remembering to activate environments. You can switch between all your projects, and pyenv will take care of automatically activating the correct Python versions and the correct virtual environments. In the next lesson, we'll have a look at activating multiple environments simultaneously. Let's say you want to use the black and isort formatters for the Bree project. Instead of adding those formatters to each project, I usually create a virtual environment specific for those tools and activate both that virtual environment and the actual project virtual environment. So let's start by creating a virtual environment named formatters from Python 3.9.0, after which you can use pyenv shell formatters to activate the virtual environment, install black, and install isort using pip, and unset pyenv shell. Let's clear the screen and check pyenv version, which will show that you're still in the Bree virtual environment. And when you run the black command, pyenv will tell you that this is not found in the Bree virtual environment, but it is found in the formatters virtual environment. So how would you access black and isort while you're working on the Bree project? You could use the pyenv shell each time you want to run them, but there is an easier way. After all, this lesson is about activating multiple environments simultaneously. So let's do that. While you are in the Bree project directory, run pyenv local Bree formatters. Now, when you run black, you will see that it works just fine. But how does this work? Well, when you take a look at the .python-version file, you will see that both Bree and formatters is in there. When a command is not found in the Bree virtual environment, then pyenv will try to resolve it in the formatters virtual environment. When the command is not found there either, like when you run a command called Mordor, an error will be raised. Now that you know how to work with multiple environments and Python version in the same project, let's do a wrap-up of this course in the next and final lesson. Having to deal with multiple Python versions can be a pain when you try to do it only with system Python or package managers. And that is where pyenv is the tool to help you out. Whether you're working on multiple projects that require different Python versions, you want to work with multiple Python versions in a single project, or just want to try those shiny features of a new Python release, pyenv is here to help you. You will never have to worry about whether you've activated the correct virtual environment, because it will be activated for you after running a single one-time command every time you move into your project directory.